All right. Let's get into it. Let's start this process off. So here's our equation. And we are looking for the limit as x approaches infinity for g of x, which in turn is the limit as x approaches infinity of x plus b over e to the x. And with this, you in our class we talked about function races and which function goes faster, quicker, will determine on where the function goes. However, with doing this as an open response, you can't talk about function races. Like the AP people do not know about function races, but what they do know is applying L'Hopital. Hospital. So we need to use L'Hopital's rule, which states to take the derivative of the top by itself, which is just going to be 1 now, because the derivative of x is just 1, and then b is a constant which falls off. The derivative of e to the x is e to the x. And then once you've taken the derivative of the top and bottom, then we submit our x, or whatever our value is, back into our limit to see if we get something. Which we do, because 1 over e to the infinity actually approaches 0. So the limit as x approaches infinity, g of x actually goes to 0. But I would definitely talk about applying L'Hopital's rule or using L'Hopital's rule or stating that there's L'Hopital's rule. So that's all you need to do for the first one. And what do they show? Do they? What are they doing? Oh, it's because of my number 2. So 1 point is earned for the answer. The limit as x approaches infinity and g of x equals 0. Students respond 1 point. So it's just 1 point if we can say that it approaches 0. All right. Close enough. Good. Oops. Keep that open. Sorry. Misclicked. Here we go. So let's try number 2. So here, let f be the given function. F of x equals x over the square root of x squared minus 4. Find f prime of x. So they just want to take the derivative. So when I look at this, this is just going to be the quotient rule. Well, the quotient rule, if our original function is u divided by v, then our derivative is the bottom times the derivative of the top minus the top times the derivative of the bottom all over the bottom square. So you can think about it in terms of that. You could talk about it in terms of u times v to the -1 power and just doing the product rule. But once you combine everything and make common denominators, you will end up eventually getting back to this as well. So the MSU senior math students in my class that are visiting for the semester taught me that one. So I will give props where props are due. Thank you. But yeah, I thought it was pretty clever. I just memorized the quotient rule and done the quotient rule so many times that it's second nature to me to do this. So how do we establish this? Well, first off, f of x is f of x, okay? Then we can establish what's on top and what's on the bottom. So u is going to be the x, and then v is going to be x squared minus 4 to the 1/2 power. I'm just going to rewrite the square root as an exponential function because then I can apply the power rule when I take the derivative. So I have u, I've got v, so I need u prime and v prime, and then I'm good to go. So all I need to do is take the derivative of this, which is 1, take the derivative of that, which is 1/2. The parenthesis stays the same, subtract 1 from it, and then times it by the derivative of the nested function. So when we look at this, we're going to take the derivative of that whole thing as well, which is just 2x because the constant falls off. But this still needs to be applied as well. So when I look at this, and then whatever's in parentheses stays exactly the way it is. So if we were to rewrite this with the exponent not being negative, let's talk about what v prime actually is. Well, the 2 and the 1/2 would cancel each other out, and I'd be left with just the x on top, and I'd be left with x squared minus 4 to the 1/2 power, which is square rooted, on the bottom. So now if I substitute all of these, u prime, v, and v prime, into this, I will get my final solution. Now, we might need to clean it up a bit, but we would do v, which is x squared minus 4 to the 1/2 power, times u prime. So the bottom times the derivative of the top, which is just 1, minus the top times the derivative of the bottom, which is x over the square root of x squared minus 4, all over the denominator squared. Now, what happens to a squared and square root sign? They one each other out, and I'm just left with x squared minus 4. All right. Now, if we clean this up a little bit, which we would want to try and work through a little, we could say x squared minus 4 to the 1/2 power. That's still okay because times it by 1 doesn't change it. We're going to put the x up top here, and we're going to get x squared over the square root of x squared minus 4. And then this whole thing is divided by x squared minus 4. Now I can put it underneath and deal with that. But really, I think what I want to do is combine these very quickly to figure out what's going to be going on. Or, instead of dividing, we can multiply by the reciprocal. And if I multiply by the reciprocal and distribute it inside, I'm going to be left with 1 x squared minus 4 to the 1/2 power over x squared minus 4 minus x squared over x squared minus 4 to the 1/2 times x squared minus 4. So it's about working with the exponents at this point and really knowing your exponential rules. So when we have exponents multiplied together, we want to add the exponents. When we have exponents divided by one another, we want to subtract them. So when I do this, I could, if you really want to think about it that way, but I could break this up into x squared minus 4 to the 1/2 power times the 1/2 power. So I could have two sets of these because a half and a half add together to make a whole, so that one of them cancels out. So I would be left with 1 over x squared minus 4 to the 1/2 power, because one of the 1/2s would cancel out on the top and bottom. And then this one, minus x squared this would be x squared minus 4 to the 3 halves power, because that's missing up there. Well, if we wanted to continue this process, which is kind of daunting, but it is what it is. Let's do this, because I think I know where they're going with this. Also, I would make sure and utilize my time. If I got to this point, I might stop here on an open response and continue going on. And if I had time, maybe come back. But if I make the common denominator 3 halves, that means I need to put an x squared minus 4 up top here, because that's what it's missing. Minus an x squared. And then x squared minus 4 to the 3 halves is already there, so I don't need to multiply anything by the top and the bottom. And if I do x squared, take away x squared, those disappear. And all I'm left with is a negative 4 up top, and then an x squared minus 4 to the 3 halves on the bottom. This would be the ultimate final answer in simplest form. Now, depending on how crazy, yeah, they might just be this. I'm curious on what AP Central has to say about it. Negative 4 over x squared minus 4 to the 3 halves power. Yeah, see, student response earns 2 points for earned further solution. I think it's very funny. And I've said this to my students before, but like with AP Central and wanting to make sure how much of this is calculus and how much of this is basic mathematical manipulations, you know, we did the quotient rule. We applied the quotient rule. Why is it so significant that we get the simplest form of it without a calculator? Does that prove my calculus knowledge? I don't know. I guess if you're going to get calc credit for it, you've got to demonstrate all the previous knowledge for it. So maybe they're kind of like overworking the fact, like, can they do algebra 1, algebra 2, those types of things with this manipulation? So I can understand it from that point and why you're getting AP credit, but man, they make you do a lot sometimes. For an answer that, if you told me to plug in an X value, I could have stopped way back here, plugged in the X value, and just gotten my final solution without a calculator very quickly. Where trying to find the simplest form of the answer, I really had to like work for it. So, I told my class I'm going to do the first 2 problems today. I'm going to do the second 2 problems on Wednesday. And looking at those, we can look at those. Maybe get some hints out. Let's hide the scores. So for this one, the figure above shows the graph of f prime. So first things first, know what graph you're looking at. That's so important. You so got to know what graph you're looking at. And when, excuse me. When looking at graphs like this, if this was, let's say this was the original graph, we would know that the original graph was decreasing from -7 all the way to -3. So, and then here is a 0. So that could be a potential max or min, you know? And that's how you start to read this. And then we go to increasing till we get to probably 2. And then it starts decreasing. And then this is a vertical slope. And then it continues to decrease and then levels out and then goes back to increasing. If that was the original function, that's how I would read it. But we have the derivative. So everything still applies to the next derivatives graph. It means it's really concave down from -7 until -3, because we don't turn around, because this is at 0, because the slopes of the tangents And the slopes of the tangents are the derivative of the derivative, which would make it the second derivative, which talks about concavity. So all of these are going to be decreasing. Then we are going to increase till we get to here. And then we're going to start decreasing again. There's going to be something that happens here where it's undefined, and then it continues to decrease and then turns around and increases. So that's how you want to start to look at number 3 for this question. I don't want to give any more away yet. I want you to think about it and really try and work through it. But we'll talk about We'll talk about that on Wednesday. And then number 4. Here is your chart. These are very famous Riemann sums for sure. Like, this is the type of question you're going to get for a Riemann sum. Okay? They want you to write the integral and expressions in terms of h. We are going to learn that tomorrow, so I'm not worried about that. And then it says, estimate the average temperature of the oven using a left Riemann sum with 4 subintervals of equal length. Now, that is something we've done and we did last week. So that's applying last week's knowledge. And how are you going to set that up? So yeah. What is that? Can we insert an image? Oh, you can. So you could actually draw it on a piece of paper. I'd be curious on how you could take the picture. Maybe, I don't know. What is this? Bulleted list, numbered list. Okay. I'm trying to think of ways where we could actually draw the Riemann sum picture. Because this is one where the picture of the 4 rectangles would be very beneficial. And I think which represent it very well. You might just have to explain that in words. Very tricky though. Clear all. Okay. So, no questions in the chat. What about in here? And for people that do eventually start to watch the questions page right here, if you had a question, you could take a picture, put it in here so that I could see it. And then we would work through that too as well. I would guarantee time anything that was put in the questions tab. I just do the AP calculus for filler so that I actually go live. I don't have to go live for an hour. I want to just make sure I at least go live for a little bit though. And do what I do. All right. So, unless there's anything else, have a blessed day.